everyone, I'm Andy from Adaptronic and welcome to the introduction to volumetric efficiency or VE tuning. As far as I know, Adaptronic were actually the first guys in the aftermarket world to introduce VE tuning. We implemented it back in December 2009 and since then most of the other aftermarket ECU manufacturers have introduced it as well. The main benefit is that it allows you to generate a base map really quickly, and even if you don't have all the details of your injectors, it's still a lot quicker than to guess millisecond values from scratch. Here's the theory. Every time an engine goes through its complete cycle, which is 720 degrees for a 4-stroke engine and 360 degrees for a 2-stroke engine, it draws through the swept volume multiplied by the volumetric efficiency. For example, a 4-litre engine operating at 80% volumetric efficiency will draw through 3.2 litres of air in the 720 degree cycle. Knowing this, as well as the manifold air pressure or MAP and the air temperature, the ECU can calculate the mass of the air going through the engine. Knowing this and the target air-fuel ratio, the ECU can work out what mass of fuel to inject. Knowing the desired fuel quantity and the injector flow rate and the injector dead time, the ECU can then work out the millisecond value from that. So here are the steps that you need to follow to set it up. First of all, enter the engine capacity in cc's. Secondly, set your injector type. At the moment, the ECU supports the ID1000s and the Deutschwerk 720cc injectors in non-stage injection mode. If you're using other sorts of injectors or you're using these as in stage injection, then you need to select dead time and flow. But if you are using the ID1000s or the Deutschwerk 720s, then select the injector type and enter the fuel pressure in kPa and select whether it's a manifold reference regulator or not, and the ECU will work out the flow rate and the dead time based on the current voltage and fuel pressure. Otherwise, if you're using Injector Dynamics 725s, 850s, 1000s or 2000s, you can go to the primary injector dead time setting, select the injector type and enter the fuel pressure, and then click set. The software will then enter in the dead times for you based on that fuel pressure and injector type, and also calculate the injector flow rate. If you're not using stage injection, make sure you set the primary 2 and the secondary injector's flow rate to 0. If you're using any other sort of injector, then enter the injector flow rate in cc's per minute in the primary injector setting, and again make sure the primary 2 and the secondary size are set to 0, and then go to the primary injector dead time setting and enter the dead times as a function of the battery voltage at the fuel pressure that you're running them. Note that a value of 1 in here corresponds to 10 microseconds, so if the dead time is 1 millisecond, then you'd enter a value of 100. If you're using staged injection, then the injector type has to be set to dead time and flow. You can still use the Injector Dynamics characterization built in the software by going to the set primary dead time, set secondary dead time settings, selecting the injector type that you're using, entering the fuel pressure, and then the software will set up the dead times and the injector flow rate based on what you've set. Otherwise, you have to enter the dead times manually and the injector flow rate manually as well. If you're using 2 stages of injection, as on an RX-7 or the Series 2 RX-8, then you need to make sure the primary 2 injector size is set to 0. And if you're using 3 stages of injection, as on the Series 1 RX-8, then set the primary 2 injector size to your secondary set of primaries, and also set up the primary 2 injector dead time. The next thing that you have to do in the setup is make sure that your target air-fuel ratios or lambda values are set appropriately for the engine. From there, start with a fuel map of constant values of say 80 or 100, and this will allow most engines to run pretty much straight away. From there, it can be tuned as normal. Note that with this configuration, you not only get a lot more resolution than you do with tuning with milliseconds, but because the values don't change a lot from one load site to the next, it's a lot easier to spot an incorrect value. One final point, the air-fuel ratio value in the gauges window gives you 3 numbers there. The first one, which is the one outside the brackets, is the actual value that the ECU is using. So that could be from the analog wideband input, analog narrowband input, or the serial wideband input, which overrides the analog one. The first number inside the brackets is the analog reading, which could be from wideband or a narrowband sensor, and the third one is the target air-fuel ratio. So during your tuning, you're trying to adjust the fuel map so that the actual air-fuel ratio matches the target. If the target's not where you want it, then you need to go in and adjust the target air-fuel ratio table. Once this is done, you can adjust your target air-fuel ratios, and the ECU will automatically change the injector milliseconds to compensate. For more information, please go to adaptronicecu.com.